Hi guys, thank you for coming to OLED Wave paper reading channel. Today I'm going to have a very quick review of Apple's newly published SOTA Multimodal Large Language Model, aka MM1. And we're a channel that reads latest archive papers, and we also have a weekly meetup. Please do not forget to either subscribe our channel or join our meetup to get the latest archive paper readings. So this is the general task of multimodal large language models. You can either tell how many dogs are in the pictures and how many frisbees is in the picture, and given the red circle, you can ask the model what's the text in the circle, and you can also, given a picture of refrigerator, you can ask the model to guess how heavy the stuff is. And also you can perform basic mathematical equation. For example, you detect a 1, a 3 here, you do the 1 plus 3 equal to 4. You can also ask, the model can also follow your instructions. For example, given a beach picture with beer on the table, and also a menu of the drinks, it asks how much should I pay for them. You can think other models, you can definitely do chain of thoughts and get the OCR things, and given the 2 beers, just 6 plus 6 times 2, right? You should get 12. But if you're using a multimodal LLM, you can just output the number directly. But if you're in California, but I think you have to pay tax and tips. All right. This is general architecture of their model. There's nothing new compared to the published works before them. You can see there's a decoder only LLMs. Besides the textual tokens, they also take in the visual tokens, which are converted by the vision language connector from the image embedding generated from the image encoder to the visual tokens. In terms of the data, they can have just text-only data as input. They can also synthetic data. The image part of text data usually means the image with caption. And the interleaved data could be Wikipedia or web pages, that has a long article with a few images around in it. You may ask, what is a VL connector or visual language connector? This is something that in the Honeybee model, which was published by Kakao team in Korea last year. They have the benefit of being flexible in setting the number of visual tokens. As you can use a resampler, which can do the same thing, but this model, they are capable of preserving localities as the linear projector, while the resampler cannot do this. So you can see they propose the 2 types of vision language connector, new vision language connectors. They both use adaptive average pooling. They do not use average pooling only or attention pooling. Okay. In terms of Pretrain data, like I said, the 4 types of data, these are details. And the network architecture-wise, definitely a mixture of experts work, and also they learn the lessons from the setting of their models. Definitely remember, image resolution is the most important thing, and model size is also important, and also how to mix the training data from the 4 categories are also important. And they have different conclusions than the Honeybee people. They're saying this VL connector doesn't matter much, but they use Honeybee's people's VL connector. In terms of model and data, and these are fairly standard, except the language model, you may wonder why they're using 1.2 billion parameters. Actually, they're just putting number here. And in the later experimental section, they demonstrate that you can always use bigger larger language model up to 30 billion parameters in their paper. In terms of the image encoder and large language models, they're initialized from their in-house pre-trained models, which says which means they do not use any open source model like the Honeybee people. Honeybee people use the Mistral 7B, according to my information. You can see the Pretrain evolves. You can see it does better than other previously released open source models. Don't forget this. This is a pre-training, not SFT or supervised fine-tuning. And you can see you can perform 0 shots or multiple shots, a few shots. And you can see they perform significantly better than the other models they compared in this paper. When you move on to the supervised fine-tuning, they can perform visual instruction tuning, which is not invented by them. And also they concluded that it's important to scale to higher resolution. They did use a published work called positional embedding interpolation, like people use in the large language model or BLIP2. And they also use sub-image decomposition in this paper. Sometimes the image is too big or resolution too high. What they did is for the first image is the downsampled version of the higher resolution image. And these 4 images are from the top left, top right, bottom left, and bottom right of the upsampled images. Okay. And then once after they did this, they got a sequence of image embeddings. Then they use a veil connector to get a sequence of visual tokens. And about the data for their SFT, this amount of the sample they used, indeed, is not that many. The first type is instruction response pairs generated by GPT-4. This is the place that they leverage the open source, or what do you call that, external data source, right? Because you can see their model size is not bigger than 30 billion parameters. Not very big, but GPT-4 and GPT-4V is definitely something around 200 billion parameters or more. That gives, this is like doing the noisy student training or transfer learning. You use the bigger model to generate some data and use that data to help with training your smaller model. And they also use the data sets from academia and also use a text-only database. The lesson learned is roughly same as they learned from the pre-training. And they also say the careful mixture of the image and text is important. I guess the reason could be mainly because their test set is composed of subtasks. And sometimes the subtasks, they are mostly caption data-based task. Sometimes the task is just text only or text core task. No image is evolved. So this is why making your fine-tuned data or data for training matched to your test case or evaluation case could give you a gain in the final performance. Of course, synthetic data helps. This is the other results, and they did not compare with the Honeybee model's performance. One of the reasons I think it could be, it's not apple to apple because they train their own large language models, but Honeybee people, they just plug in a Mistral 7B model and fine tune on top of that. Another reason I think was because the model size are way different, because you can see the number, they have 30 billion parameters. And also I think these guys, Apple guys, they use GPT-4 and GPT-4V to generate some data to help them training the model. The settings are different. But I checked the Honeybee's paper. These Apple people, they do get better results on the VQA tasks. Okay. All right. You may notice that we are a data vendor. We provide bespoke data solutions. We also help people to curate customized text token, text, visual, and voice data sets or we do automatically labeling your private data. And we also provide tech consulting service in ASR, TTS, and all other speech-based applications. All right. We just want to assist you to build your stuff because nowadays with so many open source model, it's super easy and feasible to do it yourself. Thank you so much for coming to our weekly paper reading session. And please keep tuned and don't forget to subscribe our channel. Thank you very much. Goodbye.